Hi everyone. So the goal of this video is to understand electrical circuits. So electrical circuits usually have a battery and maybe some other device like a light bulb that uses the energy from the battery, and then maybe some other components like a switch, definitely some wires. You might see pictures like this, and this might be a should do assignment where you can maybe learn what all these different things mean and how do we usually represent circuits in a very easy way. But with that, let's jump into what is an electrical circuit. So some things I want you guys to understand. I want you to be able to use simulations, hands-on demonstrations, and calculations to demonstrate a knowledge of circuits. So specifically, I'm looking for you to build a circuit with light bulbs, batteries, wires, and other components. That's something that you'll have to do here in class. Explain how a circuit works using scientific language like charge, current, voltage, resistance. And then use Ohm's law to calculate voltage, current, and resistance. And then finally, can you calculate power of an electrical system? All right, so I'm going to give you a quick example of a circuit. This is a little simulation that you'll probably have to use. And so when we have a circuit, we can imagine that we have some electrons in the circuit. And the flow of electrons is really what makes electricity work. So we have a battery, and that battery is going to push the electrons in a particular direction. All right, you can imagine that this side is the negative side, and imagine any electron here is going to be pushed away from this negative side. And then this electron is going to push this electron, right? Because the negative is going to repel a negative. And so these negatives are going to kind of repel each other, and that's going to cause a flow of these electrons. All right, now the electrons won't flow until the circuit is completely closed. So when we put the switch together, now the electrons start to flow and the light bulb lights up. All right, that's the basic idea of how a circuit works. All right, so when we see a picture like this, we see this represents a battery. The battery is the voltage, and then in the wire, we have the flow of electrons, what we call current. And then if there's anything that gets in the way of that flow, we call that resistance. And there might be a switch or something like that that we can close to actually make the circuit work. A common analogy that you will hear, and one that I'll do in my video right now, is this idea of like water flowing. We can imagine that there's a pump and the battery is like the pump. It's pushing water and it's making the water flow. The flow is like the current. It's like the flow of the electrons. In this water analogy, it's like the flow of water. And if at any point your pipe gets really thin or it gets all twisted or whatever, that might be a place where there's a lot of resistance and the flow really slows down. Okay. And then the valve can be open or closed, just like a switch can be open or closed. If the valve is closed, the water's not going to flow. Another water analogy is that voltage is like the pressure. It's like how much push there is behind the electrons. All right, so you could have a lot of voltage, but if there's no flow, then you have no current. If you open up the valve, then that pressure can be released and you can actually get a flow of water. Or in terms of a battery, you can actually get like a flow of electrons. And then when we use that flow, it's usually designed so like the flow of water in this picture is making a wheel spin. For our electrical systems, we usually have the flow of electrons are doing some kind of job. They might be turning a light bulb on or turning on a device or whatever. And that flow of electrons is actually being used to do some work. And like that energy is being used to do something. All right, so very simple equation that kind of describes these things that we've talked about, voltage, current, and resistance, is voltage is going to be equal to the current times the resistance. All right, so remember that voltage is like this push. It's really like a difference in like potential energy, kind of like you have a difference in one side to the other, and that's going to cause electrons to flow in one direction. Current is the flow of the charge, and then resistance is anything that opposes the flow of that charge. And this is a little cartoon that I really like that kind of helps me understand these things. So voltage is the push, and it's trying to push these things through the circuit. And so we have this person who's like amps or amperes. That's what current is measured in. And then you have ohms. Ohms is causing the resistance to this flow. All right, so volts, ohms, and amps. Those are some measurements that we use for voltage, resistance, and current. So this is a little simulation that I might show you in a minute, but basically it just kind of shows you how voltage, current, and resistance are all related to each other. All right. And I just want to quickly go over something I said on the last slide, which is some of the symbols and some of the units. So voltage has a symbol of V. We measure it in volts. The symbol is also V, a little bit confusing. It's named after a person named Volta. So again, a lot of things in science are named after somebody. Current has a symbol of I. It's named after a scientist, Ampere, so we call it amperes. Also called amps. I'm sure some of you have heard about amps when you hear about like musical systems, right? How many amps does something have? And the symbol is A. And then resistance is a symbol R, and the units are ohms, named after a scientist, ohm. And we use this Greek symbol called omega, which is a funny symbol, but that is the symbol that we use for ohms. All right. So if I quickly jump over to like this little simulation, if you guys ever want to play around with it, you can. But basically, it shows you if you increase the voltage, what happens to the current. So an increase in voltage increases the current. And when we increase the voltage, you can see like we're just adding batteries. So the more batteries you have in a row, the more voltage you have, right? And then that means you get more current. Now on the flip side, if I add more resistance, that's going to make my current really small. It's kind of reducing how well the current can flow, right? And sometimes we represent that as like little dots in our wire. It's basically like the electrons are having a tough time flowing through the wire. And so it's kind of slowing down our current and making our current really small. All right, so you can kind of see how current and resistance respond to each other. All right, so that is a little simulation that you can play around with. You can see as voltage goes up, current goes up. As voltage goes down, current goes down. Okay. Last thing I'll talk about really quickly is power. So all electrical devices require power, right? And these are just some examples, and these are things that you might even learned about in the second quarter when we had to do our net zero energy project. Energy and power were some terms that were pretty important. When it comes to electrical systems, there's another way that we can calculate power. We just take our current and multiply current by voltage. And so a short way to say that is P equals IV. All right. So in the next few assignments, I might have you build some circuits. I might have you do some calculations to figure out if I give you voltage and resistance, can you find the current? Or if I give you current and voltage, can you calculate the power? All right, so look for those assignments in the near future, and good luck.